You need to know this proof if you're doing A-level maths. Prove the sum of the first n terms of an arithmetic series is n over 2, 2a plus n minus 1d. So the way I remember how to start this proof is just by looking at this formula and multiplying by 2. So if you multiply by 2, you get 2 lots of s of n is equal to n 2a plus n minus 1d. So this is telling me that I'm adding the sum up to n twice. So I'm just going to write my sum up to n and add it and then see what I get. So the sum up to n is equal to the first term, which is a, and because it's arithmetic, it increases by a common difference d each time. So then I get a plus d, the next one would be a plus 2d, and so on. And then if I skip to the end, I get a plus n minus 2d, and then I get a plus n minus 1d. And this would be my last term. Because we have n terms, a is also a term, which means we add up to n minus 1 difference. So I'm going to rewrite s of n, but this time I'm going to go backwards. So s of n is equal to, now just reverse the order, so this would be our first term, a plus n minus 1d plus a plus n minus 2d, and so on, plus a plus 2d plus a plus d plus a, and that's my second sum done. Now all I have to do is add them together, because over here you can see I got 2 lots of that sum. So this is equal to 2 lots of s of n, and now if I add these terms, I get a plus n minus 1d. So I have 2a plus n minus 1d here. And if I add the rest of the matching terms together, this plus this, I get the same thing. And how many of these do I have? I have n terms. So I can just rewrite this as n lots of this. Then all I have to do is divide through by 2. I get s of n is equal to n over 2, 2a plus n minus 1d. And there's my proof done.